Let's see here. So, and Kitra wants to take a look at number 6 on the web work. Of course we can. Absolutely. You got it, friend. So business first, a little bit of business. First off, thanks for showing up. Appreciate it. I'm feeling much better. I don't know what it means to still be getting a positive test. Little unnerving, but like yesterday when I sent out that email, I was just like so dead. I was just, everything was just killing me. And I was, you know how I dance around when I'm in person. And it was just like, I'll be moving around, putting on my show, getting exhausted and spreading stuff possibly. So just wanted to be on the safe side for all of us and to like recover a little more fully. So news, and then we'll go over web work. Oh, yeah, let's talk about web work really quick. So we're going to go over some of the web work for today, but there are some folks in the class who are, just to be blunt, just screwing up this chance to like get a really good grade in web work. So I tried, you know, we like talk about it and then I extend it if we need it. And some folks are still not, it's going to take more work than you're putting in. And you need to evaluate where you're at with that. Like, am I putting in the work it needs to get a good web work grade? And here's the answer. If you're not getting the web work done mostly, like I can see like sometimes it's just like, nah, I can't, I just haven't the stomach to do that last problem or two. Like that's not going to hurt you. But like doing half the web work is going to hurt you so bad eventually. Like I'll probably put out like an extra credit assignment at some point, you know, but in the end, like I'm not big on extra credit because usually folks who come ask for extra credit are folks who are like having trouble just like doing the stuff that needs to happen. And that's never going to stop. The train of things to do will never end. So it's like, you know, please try to, you know, get on it and change if you need to change. And yes, we can do, we'll talk, Lou. Next Tuesday might not work, but next week for sure. Let's see. So WebWork 3 is going to open up tomorrow. I was going to open it up on Friday because there's a lecture that I recorded for Friday. So we don't meet on Friday. You don't even have to be here at this time. But there's a a YouTube video that I recorded yesterday that is over a thing called partial fractions. And there's a link to it in World Class. Just go to content. You can get there now. I mean, don't do it now. That would be weird. Especially if like your volume came up and I heard you watching that while we're doing this lecture today. But there's a lecture there for you. It's nice, compact, no more than an hour. And it's a lot like normal class. I tell you stuff, we work problems together, and it may not be as ideal as being together, but it's what I got, and I hope it helps. So I'm going to like kind of expect that you'll have watched that by Monday. You will want to do that because our first exam is going to be coming up. So our first exam, I'm thinking right now, the 19th through the 21st of this month. So let me put that up here. So that's like a Monday or a Tuesday, Monday or a Wednesday, not next week, but the week after. And I'll give you more details as that comes closer. Let's see. So yeah, so let's see. So I told you about the web work, told you about the lecture for Friday. There's a new table that I found. I like the tables I've been giving you, I've hated. That is no more. So in the content area, the greatest table, the greatest calculus table ever created is there for you. It is the back of Stewart, which is a really classic calculus text. It's the inside covers in PDF form. And I'm going to actually just kind of like drop it to you right now because I really want you might want it for today. So I'm just going to give that to you. Okay, let's get us. Here's us. And... all right, so I'm going to drop this into the chat window, and you probably will want this for today. Let's see if I get everybody. Okay. So there it is. Great, and that is up there. That should be available for you now. And this is an ultimate math reference, not just for calc, but for a lot of classes, maybe even physics and stuff. It starts off, if you could just check it out with me real quick, please. Let's see, am I recording? Yeah. It's got like just some basic like algebra stuff and basic geometry, super helpful and will be helpful in our class in a bit, about 2 to 3 weeks. Lots of just basic math things on that first page, and then trig on the second page. Great trig reference. Even got the graphs. Page 3 has got some interesting functions that you should know. Page 4, some special functions like E, and then these at the bottom of page 4, there's hyperbolic functions, which we're going to talk about in here. And I'm going to want you to have some familiarity with. And then finally, then the differentiation rules start. And it's so cute that they have like a little dotted line and a scissors to cut on the side. So you could cut them and make them, you could cut out of your book. You paid like whatever, $170 for this book, and they want you to cut pages out of it. I don't know about that. But then that's where our calc reference starts. So derivatives, and then the next page, page 6, is integrals. And that's the rest of this table. And we're going to actually probably touch on this table today, but look at that table. My God. That is some comprehensive calculus tabling. Pretty sweet table. So don't say I never gave you nothing. And certainly don't say I never gave you a good table, because that's it. This is the ultimate. All right, so that's all the news, and I've got some web work requests. So let me take a look here. Got to log back in. Yes, and now as I peel through the homework looking, I see that many people have not started the homework. That's it's a little worrisome, but hopefully this will help today. We're going to do disintegration by parts today mostly. So, gosh, okay. What am I looking at? So first, let me go to Kittrus because it's number 6. I'm just going numerically here. Okay, number 6. Yep, we're going to talk about how to do that one today, Kittra. I'll write the problem up here. But so Kittra's problem was this one. This is number 6 on the web work. Going to talk about it today. Oh, hell, let's talk about it now. Why not? So the good news is, this assignment's all about integration by parts. So parts are needed here. This one requires a special trick. But I want to point something out before I show you that trick. Take a look at the table. Let's go back to our table. So open that table up, and I wish I had the PDF version here. Maybe I can just, there we go. Now I got a nice PDF. It's easier to look at. And let's start thinking, oh my God, I'm on the job. You're doing whatever your chosen profession is, and you've come across this integral. You have no freaking idea. Maybe parts. I remember him saying something about that, but you don't really know. So you go down to the integral table and you start looking for something that looks kind of like this. And this isn't a cheesy method. This is like, you're out in the wilds having to do it. So I keep going. I'm on page 8 already, and I haven't seen anything that looks like this. But now I'm down by the trigs stuff on page 9. And then page 10. Oh, look at page 10. In particular, look at formula 98. And please, play along, because this is going to be very helpful to you on the next web work and like the exam and so forth. So if I sort through here long enough, I see this formula 98 that says integral of e to the AU sine of BU du is equal to e to the AU over a squared plus b squared times a sine of BU minus b cos BU. And then that's all plus c. Oh my God, I'm done. Because all I have to really do here is lay that formula on top of what I've got and see what's what. So does it seem, so first off, can you do this? Just take a minute. Can you do this problem using the formula? Make sure that that actually works for you. Do you see how to do that? There's one thing for me to tell you, but it's a better thing for you to know. Copy the formula right? Yes, it did. And with a little simplification, I'm done. So Kitra, that's one way, and it's not wrong by any stretch. Totally kosher way to do that. Does anybody have any questions about how I moved from the top to the bottom? No? Awesome. So on the web work 3, in fact, problems 8 through 12. So on web work 3, problems 8 through 12 are table problems. You can do them with the table and should do them with the table. Problems 1 through 3 are just some more parts. Problems 4 through 7, getting pretty crappy with my writing there, are Friday's lecture. So you'll have to watch that video on partial fractions. So that's Friday's lecture, but it's there so you can do it whenever you want. And then problems 13 through 15, who knows? It's up to you. Might require any of the techniques we've talked about this semester. So 13 through 15, mystery problems, which is basically what life is like outside of calc class. You don't get a problem to solve and they tell you what technique to use. So we're going to practice more of that. And then Monday, we'll be practicing that a lot when we get back together in person. So let me show you how to do this a different way. That's one way. with formula. Second way is I'm going to use integration by parts. And you just need to see this once to really understand how to do it. I don't even think it's like something I'd put on an exam because it's just such a niche kind of thing, but you need to see this. So let's use parts. Because I see a product of two things, I want to integrate them. Each one on its own is chill. But neither one of these becomes simpler when I differentiate it, right? Remember, so like just fresh in your mind, we have to pick a U and a DV. And the tip I gave was let U be the thing that gets simpler when you differentiate it. So like X to a power, a positive power gets simpler. We don't have that here. So I'm gonna go like that because neither one of those gets simpler. They just kind of oscillate and change a little bit. All right, let me give you another special rule over here on the right. We're going to need this like crazy for the rest of the semester. These are special rules to remember and maybe just have on a note sheet. You'll have a note sheet on the exam. I would put these on there. If I have integral of e to the kx dx, so k is just a constant, then that's just 1 over k e to the kx. If I have integral of sine kx, that's negative 1 over k cos kx. Integral of cosine kx is 1 over k sine of kx. These are just really great that come up a lot. And you would need substitution normally to get that 1 over k out in front, but if you just know that's kind of how they roll, you're good to go, and it helps. So I highly recommend having those on a little sheet of paper or just the great sheet of paper upstairs. All right, so I'm going to do parts. Differentiate, integrate. But I've got my sweet rule, so I don't have to think hard about that. And then I write the next step. Notice how I labeled this. That was a weird move, right? That was a weird thing to do because I've never done that before, but we're going to keep track of something here. So this is I equals, now I've got UV, remember our formula. Even that's in this sheet. Even integration by parts is in this master sheet that we have. So I've got UV, which is negative 1/5 e to the 2x cos 5x, and then minus integral v to u. But look, that's going to become plus because of the minus on the 1/5. I'm going to pull that out in front. Integral v to u. Let's keep the order on the trig parts and the exponential parts the same. So I'm going to stop there. Please let me know if that makes sense. Yes, I'm seeing some nods. Cool. Anybody need any clarification on that at all? Good. All right. So, oh no, look, nothing got better. I've just got another integral e to the 2x cosine of 5x that needs parts again. So that kind of stinks. It doesn't feel like things got better, but we have to have patience and faith in math. So what we're going to do is parts again on that second one. So we're going to do parts on this fellow here, and we're going to let u equal e to the 2x again. And I'm going to let dv be cos 5x dx. And then do my parts. So du is 2e to the 2x dx. V is 1/5, because I'm using my slick rules, sine of 5x. And I'm going to write out what I have now. So I, the original integral, now check this out, that 2/5 is times that whole integral. So I'm going to use a bracket because I'm going to put the uv minus integral v du inside there now for the parts on that new integral. And I got to keep everything straight, so I want to organize. If you're an organizer, you should love brackets. They're the best. They're like, powerful parentheses, because a lot of stuff's going to happen. So now we've got uv so right there, that's just uv, the new uv, minus integral v du. So I got to make a little box here. This is getting kind of shitty, but v du is going to have a 2/5 out in front because of the 2 and then the 1/5. Integral e to the 2x dx, e to the 2x sine of 5x dx, and then bracket. So that's the minus v du part. Let me stop. Oh shit, nothing got better, did it? Or did it? Do you recognize anything in there? Do we see an old friend manifesting in there? I see this integral here. Does it look familiar? Is it a face we've passed in the math hallway? Where have we seen that integral before? Like a good tea sipping time. Oh, yeah, the OG integral. Okay, awesome. Yeah, I just got a text here from Lou. Not Lou. Who's that? Who sent me that text? That is Lou. Okay. Hi, Lou. Sorry. Yeah, I saw the BEC and I was like, who's that? Cool. So solid, Lou. So this is the original integral I. Oh my, let's write out what we have. So we have I equals negative 1/5 e to the 2x cos 5x plus, now I got these parentheses, so this is going to be, or this bracket, so that's going to become 2/25 e to the 2x sine of 5x. Now check it out, this 2/5 out in front of the bracket interacts with this negative 2/5 in front of the original integral. So this becomes negative 4/25 I, the original integral. So let me stop for a second. Take this in. This is like one of those special moments in calculus class. Like in any relationship, there's special moments. This is the first time you held hands, right? Or something like that. And you remember these times. That's what this is right now. So let's make it special, right? Let's be present. Let me know if there's anything that needs clarification, because we're almost done. There's no more integrals. So what I'm going to do is take this thing here and move it to the left side. So I'm going to add 4/25 I to each side. And what I get then is 29/25. Why can't I write that? 29/25 I. That's 1 plus 4/5. Equals this dastardly expression. And now I can solve for I, which is what I wanted to begin with. So if I multiply both sides by 25/29, I'll have I on the left side equals some expression on the right, and that's my answer. So this thing involved doing integration by parts until we found the original integral popping up again, and then we labeled that I and solved for it. So it's a really strange technique, but let's come back. Let's summarize right up here. So I equals 29/25 times this. I didn't tack on the plus C yet. I'm about to do it. Oh, I guess that'll help. I guess we'll do it right now. Plus C. And you're done unless you want to simplify, and we do. I feel you. We want to simplify. So the original integral equals negative 29/125 e to the 2x cos 5x plus 58 6/25 e to the 5x sine of 5x plus c. Or you can use the formula. Your choice. But we get the same answer both ways. But this is how they came up with that formula. This is where it came from. So there. Let me know if you want to talk about any of that. That's pretty intense. And kind of beautiful and cool that someone even thought of that. So that's how you do number 6. That was a long talk about number 6. That was yours, Kitro, right? Yeah. So you good on number 6? Yes.
Dr. T, where
Yes.
did you get e to the 5x?
Maybe I screwed up. Oh, good question. I miscopied somewhere. Thank you, Josh. Down here at the very bottom of the page, that should have been 2x. Thank you. I miscopied the top line, so thank you. Thank you so much. Good call. Deeply appreciated. All right. I've got more requests. I've got number 10 and number 12 that are requested by Fernanda. So let's take a look at those problems. Cool. Is it okay if I flip the page? Anybody need? Yeah. Okay. Great. And it's recorded, so you can check it out again. So number 10 looks something like this. So on this one, Fernanda, definitely parts, right? We know that much. And I would let you be, so I've kind of changed the problem just a little bit, but here I would let you be the thing that gets simpler, which is going to be just that z thing. And that let it be that whole expression, the whole z plus 3. And then dv I would let be e to the 7z. And then when I do du, it's just going to be a straight old dz. And now check this out. Now I can use those cool fast rules. So when I integrate this, just because it's z, it's 7z, it just goes 1/7 e to the z. And so from here, so I'm actually not looking at your particular problem, Fernanda. I could look at it because I know you said you were trying and it wasn't flying. Is this the approach you took?
Yeah, it is. But
Okay.
I don't know. I think I messed up in my math probably.
Yeah, yeah, because this is the right way to go. Let me take a look here real quick. Yeah. Oh, yes. I think, okay. So I think I see what happened. So let's keep going with this, Fernanda. And I think you'll see I think you just have the UV. I don't think you did the minus VDU. That's what I think happened. Maybe that's what happened. So let's do this here. So we do UV minus integral VDU, and that's going to be 1/7 times 7z plus 3. I like to say Z the German way, Z. That's nice. That's kind of cool. So I always forget to, but I always wish I had once I'd say Z. And then minus integral VDU. So I'll put the 1/7 out in front. Oh shit. Hello. I didn't do the V completely. Oops. And then now minus integral VDU. That. So Fernanda, it kind of looks to me like you've got like this part, but not the minus VDU part.
I think that's what happened.
Cool. Okay. So I think that's the problem on that one. Does that make sense? Yeah.
Yeah, it does.
Okay, awesome. And let's take a look at number 12 then. So number 12. Oh, number 12. What a beautiful segue. Thanks, Fernanda. So let's take a look at number 12, because I want to show you, this is a technique that I promised we'd talk about today, last week. Yeah, last Friday. But we didn't get a chance to. So it's perfect for this problem. The problem is something like this. So, just looking at your answer, Fernanda, it doesn't look like obviously wrong to me. But let me show you this way that might help you keep things in a just more organized, so you can make sure that there's no math errors. This will
Okay.
definitely minimize math errors. So I'm not going to exactly do your problem, but I am going to do a problem like it. So let's take a look at this. What if I had x cubed sine of x dx? Oh, Lord. I don't know if you remember, but we did some problems that required multiple parts. This would require parts 3 times. See, right? You kind of remember that? Yeah, is that ringing some bells? So, but that's like so prone to error because you've got nested stuff all over the place. It's so easy to screw up. So I want to show you this technique called tabular integration. And I mean, you can use this for normal parts, but I would recommend saving it for when you see like multiple parts required. And multiple parts required are where you have like, you have some x to the n, and then you've either got like an e or a e to something, or a sine of something, or a cosine of something. So this would be best for these situations right here. You're not going to have all, if you have all of them, God help you, go look in a table. It's going to be a real mess. So tabular integration says we start with this table with not surprisingly, and you're going to need 3 columns. The first column is way too big here. This first column is just going to be sine. And then the second column is going to be the thing I differentiate. And the third column is going to be the thing I integrate. So what I would do is pick the thing that would be u. This differentiate column, this would be the u, the thing that gets simpler when I differentiate it. So gets simpler with differentiation. And then the integrate's the other part, just like whatever. This is essentially like the dv part. So in this one, I think it's clear that we want to go with x cubed for the differentiate part. And the integrate part then would be the sine. So what I'm going to do is differentiate the differentiate part until I hit 0. 3x squared, 6x, 6, next row is 0. So I'm just differentiating that down to ground level. And then I'm going to integrate. For each time I had to differentiate, I'm going to do the integrate part and bump it up, antiderivative. So negative cos x, negative sine of x, cos x. And then lastly, I'm down to, why is my brain frying? Sine of x. I think I got those right. Let me know if I screwed up. Those are all supposed to be antiderivatives of each other. So I can just go backwards. Sine, derivative sine is cosine. Derivative cosine, negative sine. Okay, I done good. That's all okay. Next step, that sine column. We start with a plus. And then each row we alternate that. Oh, wow. So you don't really need to go down to the 0 row. You'll see what I mean in a minute. So here's where it gets a little weird and you got to be careful. We're going to associate, we're going to multiply across a strange, like kind of diagonal pattern. So the pattern's going to look like this. I'm going to multiply like this. So notice how I'm grabbing the sine and the derivative part that are across from each other, but then dropping down to the next integrate part. So there's like that little skew there. So, and we're going to multiply on the red lines. And I'm going to add the results together. And I'm done. So let's do that. So this integral is going to equal, and you don't need to put the plus, right? You know it's plus, negative x cubed cos x. The negative came from the negative cosine, so I pulled that out in front. And then negative, so I got negative 3x squared negative sine, so that's plus 3x squared sine of x. And then I've got plus 6x times cosine of x. And then I've got minus 6 sine of x. And then I put a plus c, and I'm done. Is that good, Fernanda? Does that look way better?
Yeah, you made it seem so easy, like so simple. Not easy,
is.
simple.
Awesome, awesome. Yeah, it is. It's easy and simple. It's both those things. I mean, don't go tell that to somebody who's never taken calculus, you know, but like once you got the calculus savvy, this is easy. Isn't that sweet? Doesn't that beat like multiple parts and thousands of parentheses?
Yeah, it does.
Yes, yes. Oh man, you are like cheerleading me. You are like totally helping me out here. Thank you. So let's do one together. Here's yours. Remember the special integrate rule on e to the kx, right? A 1/5 is going to come out in front every time you integrate, another 1/5. So be really careful of that. So let's go. I got my table filled out. Make sure you get it, but sanity check is available here for you. Oh, sorry, I missed your DM before, Josh, but I think you ended up asking it. So, yeah. Looking good, Kelby. I think you're frozen. Indeed, are very concentrated right now. Lou, do you mean Lou, if I had just, yes, I think yes, that's the answer. Yes is the answer to your question, Lou. Oh, Kelby, you're back live. Good. You were like frozen for a little while there. Yeah, I just got a request for number 7. Oh, I see why. Oh, let's stick with this one first. How's this feeling? the one we're all working on together, getting some thumbs up. Any questions, any like, yeah, awesome.
Dr. T, I have a quick question.
Yes.
I don't know if I missed it or not, but what are the scenarios that you'd use this table for? Is it just when it's like integration by parts, or?
Yeah, it's just integration by parts when you have, I thought I wrote it here, but you have like a power of X, and then you have E something, sine something, cosine something. So it's a prod, it would be a parts thing, but yeah, I think this is where you have a power of X that could be U that gets better as you like differentiate it. That's the thing.
Okay, thank you.
You're welcome. All right, if there's no questions on that, I'm going to check out number 7. Which looks something like this. I'll kind of tweak it a little bit. I'll make mine much more interesting. This is the one we're talking about, Josh? Yeah, awesome. Cool. So yeah, I mean that looks evil, right? But remember, there was like a little tip I gave last time. When you have a natural log in there, you probably want to let U be the natural log. So first off, let's just write this as a product, because it doesn't look like a product right now. I'm going to pull that 3 out in front. But it's log, ooh, good Lord, log X times X to the -5th dx. So that step right there is really important, Josh, just to get it to look like a parts thing. And then I'm going to let U equal the log. And I'm going to let dv be the X part. And then I'm going to do my parts. And so now check out, and I won't finish this all the way up just so you can kind of see it, how it goes. But then when I go to the formula, it's going to become so that's the UV. And then I've got minus integral V to U, which will become a plus. Oh shit, and I've got like this 3. There's the 3 that was outside the whole thing. This is going to become plus 1/4 X to the -5th. Oh shit, damn it, sorry. 1/4 integral. This is X to the -1st. The du is X to the -1st. So when I multiply that by V, I get X to the -5th again, dx. So check that out and make sure that makes sense. And then there's, well, we got limits. Let's not talk about the limits yet. Just make sure that that part makes sense. Because we really haven't done limits on an integration by parts problem, and I want to be very clear when I talk about that. So Josh, you let me know if this is making sense.
Oh, why was it X to the -5th?
Because it's 1/X times X to the -4th. So that's,
Gotcha.
does that make sense?
Okay, yeah.
Yeah. Cool. Good question. I'm sure you weren't the only one wondering. So now we've also got these limits. So once you've got limits, you can actually do them on the UV part right away. So that means I'm going to plug in the 2, plug in the 1, and then subtract. And then I'm going to copy them back onto this one. Wait, though. So that was 1 to 2. And let's finish this up at the top. So this is going to equal 3 times. Now I'm going to plug in the 2 to that expression. So it's and then I'm going to subtract off that expression with a 1 in it. Good news, natural log of 1 is 0. So I'm not even going to write it. So no. So it just kills off that second part. That's lovely. And then I've just got to do this other integral. So plus 1/4, and I'm going to use the power rule. So it goes x to the -4th, and I put a -1/4 out in front. So that's just the power rule, and x to the -5th. And I'm going to do that from 1 to 2. And I'm almost done here. So 2 to the 4th is 16. So 2 to the -4th is 1/16. 16 times 4 is 64. Natural log of 2. And then this next one, I've got to do subtraction. I got to be careful because I got to put the 2 in. So it's going to be, so plus -1/16 times 2 to the -4th minus -1/16 times 1 to the -4th. And hopefully we all know 1 to any power is 1. So that's sweetness. So that's just 1. And that's 1/16 for the 2 to the -4th. So I'm almost done. I'm going to finish it because we spent so much blood on this. So that's -1/256 plus. Oh, Lord. And then you could add those fractions. Oh, I'm going to do it. So the final answer is that. Anything along the way would have worked, but now I think now you see what the basic idea is, Josh. And so just be careful on this one, folks. That's all I say. Like, just be really slow and careful, keeping track and things in parentheses. If it goes wrong, that's probably where it went wrong.
Oh yeah, thank you.
You're so welcome. Happy to help. Any other questions? So this assignment isn't due till, I hope it's not due till after Monday. Anybody know when this is due? I don't know. I can't.
I'm pretty sure it's due tonight at midnight.
What? No,
Yeah.
I can't. Oh, that's fucked up. We're not doing that. Hold on. We're going to change that. We're going to change that. Because that doesn't look good for most of the class if this is due tonight at midnight. So I'm going to change this homework. Yes, it is. Look at that. It's just a little fire under the keister, but I am going to move it to tomorrow because you really need to get caught up. So we'll move it to tomorrow. So now it's closes tomorrow at midnight. And we've actually done a good portion of these. Oh shit, I'll just make it Friday. What do I care? But I worry about you. I worry about you falling behind, especially if you're already behind. But I'm going to make this due on Friday. So try to manage yourself so that you can at least start that you can watch that lecture for Friday before Monday. I really want you to do that and at least start on that homework. That's all. That's all I ask. So other questions on this this web work or anything? I've got one more thing to tell you, so it's I just want to show you one more problem. Okay, cool. Let's do that. So this will help you with the web work. So when you go to that web work 3 and you're checking it out, you're going to see it refers to the table in the back of the Stewart book. Some of the problems, because I didn't write these problems, they're like pre-canned, and I look at them and like, oh, that's a good problem. And so what you should do then is look at the table that I gave you. So that new table, everything's in that table. Everything I'll ever ask you is in that. I double checked that everything on this assignment's in that table. So what if I'm doing web work 3 and it says, hey, do this. Now I've told you which problems require tables. This would be one of them. Go to that table right now and do this problem. So you have to find, so you have to do your pattern matching skills. What formula is this referring to? Let's practice using the table. And we're going to do it one more time after this. Get the table up myself. They're kind of nicely organized by patterns. It's like everything with square roots is kind of together. Fractional things are together. Oh shit. This one. What a clown show. I think, oh, please be in here. Oh, it's in there. Okay, I got scared. I didn't want that to happen. It's in there. I'll put a tip in the DMs. You don't have to look if you don't want. Just the page. I'll give you the page number in the DMs if you're having trouble. How many folks are finding it? Nobody yet? I'll put the first letter, the first number of the formula in the DMs. The first digit of the formula. Yes, Josh. Josh just told you. You can look in the DMs if you want. Formula 33. So even though it's a table with, kind of the answers there, there's still, it's a challenge until you get used to looking for these patterns. So formula 33 says this. The variables are what are queuing off the patterns. You're not going to find your specific numbers from the problem in there. It's the variable rhythm. Oh, someone asking a question. Okay, I thought that was maybe happening. So this formula, do you see how that's the formula? Make sure you see that. Yeah. So what does A equal? What would A equal for this formula to match?
3.
Thank you. Yes, because 3 squared is 9, right? So this thing here is the a squared. So I've got to kind of take a square root, identify a as 3. And then when I go to do this formula, I mean, oh shit, well, I'll just go ahead and write it down here. So this is 3 squared minus u, and you got the formula in front of you, so I don't need to write it out again. So it's, well, hell, I'm just going to go straight down here and use x. So it's -1 over x square root of a squared, which is 9, minus x squared, minus arc sine of x over 3, x over a plus c. There we go, done. I can tell you with great certainty that doing this problem any other way is very painful.
Dr. T, I have a question.
Yeah, What's
So
yeah,
do the u's always correspond to like the variable?
solid. Yes, ma'am, absolutely.
I thought it was 42, but I like that's just like the flipped version.
Wait, you thought what was 42? I'm sorry.
I thought the
Oh,
formula.
the formula. Oh, sorry. Oh, God. I was like, I thought you were saying the answer was 42. And I was like, isn't that in like life, the universe? There's some money. There's like some Douglas Hofstadter book. Not who wrote that book where the answer to the universe is 43. You guys don't know what I'm talking about? No. Okay. So let me look at 42 really quick. Ah, good. Let's have this talk. So Olivia, when I was like looking through this, I was like, shit, I saw that formula. I was like, that's the wrong one. 42, notice that the variable comes first and you're subtracting off. So it's a real, everybody take a look at formula 42. This is like the next page. Notice the rhythm there. Here we have constant minus variable squared under the radical. That one is the other way. So glad you asked that. Thank you, ma'am. Beautiful. So this is formula 33. And then we're done. And if there was limits, we could do them. We're grateful there's not because it's an arc sine. And I got one last one. Use the table. And you notice that like in the heads of the sections, they kind of like tell you forms involving this expression. So you can kind of narrow it down by that. So let's just, before we, I mean, you can go ahead and try it, but there's like a little subtlety here that I want to talk about. Come up with what you think the formula is. Then let's verify that we agree. Everybody got what they think? Still, anybody still looking? Okay, it's formula 21. Yeah, do we agree on that? Do we all see formula 21? Look, that's the square root. Formula 21 says this. Square root of a constant. Doesn't matter that it's squared. It's just a constant plus a variable squared du. So that's the form we have here. Now, we have 3x squared, not just x squared. But that's okay because we know how to do U substitution. And that's what these formulas are all about. U substitution potentially. So what would A be? If we're laying these over, what would A be? But yeah, piece, right? 2. What would U be? That'll be harder to do with fingers. I would love to see someone try, but I can't imagine what it would be. So you got to think, what would U squared have to be? It would have to be that 3x squared, right? So what does that mean U is? Take the square root of each side. If U is the square root of 3x, then U squared is 3x squared. And that gives me my substitution. And now I'm going to play my substitution game. And I'm going to rewrite this formula. We haven't had this yet. We got to rewrite it so it looks like the thing we want. So du is going to equal root 3 dx. So that means dx is 1 over root 3 du. And so this thing is going to become integral square root of 2 squared. I'm just going to write it like that so it's nice and obvious. Plus u squared. Then the dx becomes 1 over root 3 du. And I'm going to pull that 1 over root 3 out in front. And now I can use the formula. Now I've made my integral look like that formula. Took a little bit of work, it's not hard. And then this is going to be the way it goes anytime you have to make that tweak. And so the formula says, okay, so this is 1 over root 3. Now I just go to the formula and it says that's u over 2 root a squared, which is 4, plus u squared plus a squared over 2 natural log of u plus square root a squared plus u squared, evidently, plus c. It looks pretty sloppy there. I'm going to clean it up and put it at the top. And then I have to back substitute because I didn't have the original problem in u. So my final answer, because u is equal to square root of 3x. Oh, shit. Okay, did I erase? Okay, there's that. All right. So this is going to be 1 over root 3 square root of 3x over 2 square root of 4 plus u squared, which is 3x squared, plus 2, because that's 4 over 2, natural log of square root of 3x, that's the u, plus square root of 4 plus 3x squared, close that bracket off, plus c. Good Lord. I mean, holy hell, if you had to do that by hand, I feel empathy for you. Feel great empathy for you. Even though it would be fun, not saying it's not fun, it's a lot of work. A lot of work. Even that was some work. And we had the table, right? But it's, I can tell you, it's at least an hour's less work than by other ways we could do this. So that's it, friends.
Dr. T.
Hi, Olivia.
So on the last problem, did you find like du and dx, or did you just plug it in?
So in the last one, I didn't find it only because, that's a great question. Because look here, like what would you have to be for these to match up? You would just have to be x, in the last one. So then du would just be dx, and everything worked out nice. I should have addressed that, but so I was kind of doing it, but like it doesn't change anything. U is equal to x, so does that make sense?
Yeah.
Yeah. If this had been anything, if this had been like this, let me go real quick and answer your question a little bit better. Something like that. Then I would have had to let u equal 2x to make a match up perfectly. Does that make sense? But yeah, this one, so we started off with kind of like a low grade one where we didn't need to do the u substitution really. And then the next one was we upped the ante just a touch. So there's at least one like this in the web work. Maybe more, but no more than 4. So. All righty, friends, any other questions? It was a heavy day, a lot of stuff going on. So what you got to do is watch that little lecture and take the video that I made and put on YouTube, and remember the link's in World Class. Interact with that. And you can do something you can't do in normal class with that. And I stop you, like in the video, I say, okay, here's the problem, stop the video. And you can just hit pause and go work it and then come back when you're ready and we'll go through it at your own pace. So that class is nice. It's not like personal, but it kind of is. Like I was thinking of you. And so use it, work along with it like you would in class, and you'll get way more out of it. Sound good? All righty, my friends. I look forward to seeing you in person on Monday. Shoot me any questions you got, and I'll do my best to answer. I'm going to be in situations not the great. Oh, by the way, Lou, are you still here?
Yeah, I'm still here.
Awesome, cool. So I'm going to hang out and just talk to Lou really quick. Does anybody else need to talk about anything? Awesome. Thank you, my friends. Have a wonderful weekend. Bye. Bye.
Thank you.
Thank you. So let's make sure we're still just you and me, Lou. Hi. Okay, cool. So I thought we could just maybe, oh, hi. Hey. I thought maybe we could, let me stop the